So question 22 is a geometry question. So in this question, we have let triangle XOY be a right angled triangle with angle XOY equal to 90 degrees. So if we like have a triangle with XOY, and XOY is 90 degrees, we let M and N be the midpoints of the legs OX and OY. So M is the midpoint of OX, and N is the midpoint of OY. And we're given that XN is equal to 19 and YM is equal to 22, right? And we want to find what is XY. So the idea for this question is basically like you want to kind of use variables. So basically you can say, okay, since M is the midpoint, right? What if I call this A and this A? Then I can call this like B and this B, right? So now we can kind of just use the Pythagorean theorem, right? So like if you look at this like green triangle, like triangle like XON, we know XN is 19, right? So we know that the sum of the squares of the legs has to equal the square of the hypotenuse. So we get that 2A squared plus B squared has to equal XN squared by the Pythagorean theorem. So you can just write this as 4A squared plus B squared is equals to 361. And then you can look at this like yellow triangle here, which is triangle like MOY. And we can use a Pythagorean theorem on that. So we know A squared. We know A squared plus 2B squared has to equal YM squared, which is 22 squared. So you can write that as like A squared plus 4B squared equals 484. So now we find that we have two equations and two variables. So we could solve for A and B, but like I guess like a better way to do this, a faster way, would be like we want to find what is XY. So now we just apply the Pythagorean theorem on like on this like on the big triangle, right? On this like entire triangle. So we have that XO squared plus YO squared has to equal XY squared. So XO is 2A. So 2A, 2A squared plus 2B squared has to equal XY squared. So this expression is 4A squared plus 4B squared. And that equals, you can factor out of 4 times A squared plus B squared. And that has to equal XY squared. So now all we have to do is find what A squared plus B squared is. So from these two equations here, what you can do is you can add the two equations. The idea for this is like we kind of have symmetry and we want to take advantage of this symmetry. So if we were to add the two equations, we would get 5A squared plus 5B squared on the left side. And then on the right side, we would get like 361 plus 484, and that would give us 845. So we get this, and then we can kind of divide both sides by 5. And you get A squared plus B squared is equal to 845 divided by 5, which turns out to be 169. So we now know A squared plus B squared is this. So we can kind of substitute that into here. And we get XY squared equals 4 times 169. So XY, you can solve, you get like 26 as the answer. And that would give like choice B, which is correct. Yeah, so I think for this question, like all you needed to do really was just apply the Pythagorean theorem. Like in this case, we just found 3 convenient triangles that have a right angle in them. And we just kept applying the Pythagorean theorem over and over again. And we just got a bunch of equations. And then we kind of, technically you could solve for A and B, but we took advantage of symmetry instead. And instead we just directly found XY squared. So yeah, that's how we basically did that problem.